Hello, good day viewers. In today's question, we are asked to find the surface area of triangle PQR and the total surface area of the blue colored portion, which is this and this segment here and this portion here of this triangle. So let's label this A, this P, and this part of triangle PST here C. So here they say this line PT is a tangent to the circle at this point P here. This triangle PST is a right angle triangle, and from what we have here, it's obvious that this angle here is the right angle in the triangle. And we have here that these three line segments, line PR, line PT, and line RS are equal. So where should we start from? Let's start from these two segments here, A and B. If you look, this is very simple and clear. If we subtract the area of this triangle PQR here and the area of this segment here from the area of the circle, we are going to be left with only the areas of this segment A here and segment B. So we can label this segment D here as well and form an equation. The area of segment A and segment B equal to area of circle minus area of triangle PQR minus area of segment. So what are the area of the circle, the triangle, and the segment in question? Let's start with this triangle PQR here. Since we have the length of this side here as 6.2 centimeters and this angle here as 70 degrees, to find the area of the triangle, we still need the length of this side here and the size of the respective angles. But recall, this line PR here is a chord of the circle, and that this line PT is a tangent to the circle at point P. We know that in the circle theory, if the tangent of circle and chord meets at point of contact, the angle formed at that point must be equal to the angle the chord subtend to the circumference of the circle. So that means this angle here and this angle here are equal. So we can label this X, and if this is X, this must also be X. So from this triangle here, let's see if we can find X. We don't have the length of any of the side of the triangle, but recall, we have that this line PR here, line PT, and line RS are equal. So from this now, we can substitute that this line PS here is exactly twice the length of this line PT. And so we can draw a duplicate of this triangle here. Since we have line PS to be twice the length of this line PT, we can assume a value for line PT. Let's say line PT equal to 5 centimeters. If line PT is 5 centimeters, this line PS must be equal to 2 times 5 centimeters, which is 10 centimeters. So to find angle X now, we can use the SOHCAHTOA. From angle X here, this side here is the opposite because it's facing angle X. This here the hypotenuse because it's facing the right angle, and here the adjacent. So from this here, CAH, cos theta equal to adjacent over hypotenuse. Theta is this angle here, X. Adjacent is 5 centimeters and hypotenuse is 10 centimeters. So cos X equal to 5 over 10. 5 over 10 is 0.5. So cos X equal to 0.5. To find the exact value of X, we find the cos inverse of 0.5. So X equal to cos inverse of 0.5. Cos inverse of 0.5 is 60 degrees. So X equal to 60 degrees. We can substitute directly here that X equal to 60 degrees and here also. And if this is 60 degrees and this is 70 degrees, this must be equal to 180 degrees minus 60 degrees minus 70 degrees, because the summation of angles in a triangle is 180 degrees. 180 minus 60 minus 70 is 50 degrees. So we can see that none of the angles of the triangles are equal. And hence, triangle PQR is a scaling triangle. So since we have the sizes of all the angles of the triangle and one of the length of its sides, we can use that to find the length of the other sides using the sine rule. So applying the sine rule now, line PQ over sine 70 degree equal to 6.2 over sine 50 degree, which equal to line PR over sine 60 degree. Taking only this part here, line PQ over sine 70 degree equal to 6.2 over sine 50 degree. If we make line PQ the subject, line PQ equal to 6.2 over sine 50 degree, all multiplied by sine 70 degree, which if you press your calculator equal to 7.6 approximately. So this side here, line PQ is 7.6 centimeters in length. Coming back to this part here, 6.2 over sine 50 degree equal to line PR over sine 60 degree. Making line PR the subject, line PR equal to 6.2 over sine 50 degree, all multiplied by sine 60 degree, which if you press your calculator equal to 7 approximately. So we found this side here to be 7 centimeters in length. Now using the Heron's formula to find the area of line PQR. By Heron, if the length of the three sides of a triangle are represented by A, B, and C, and S is half the perimeter of the triangle, then area must be equal to square root of S open bracket S minus A open bracket S minus B open bracket S minus C. Now letting this here be A, this here B, and this here C, if you substitute here, X equal to 1 over 2, which is 10.4. So substituting the respective values here, area equal to 10.4 open bracket 10.4 minus 7.6 open bracket 10.4 minus 6.2 open bracket 10.4 minus 7, which if you press your calculator equal to 20.392. So we find the area of the triangle to be equal to 20.392 centimeters squared. The unit of area is meters squared, but this is in centimeters, and therefore this will have to be in centimeters squared. So we can come directly here and substitute it. Now coming back to the area of the circle, the formula for the area of a circle is pi r squared. Pi is a constant which is 22 over 7, but r, which is radius, is unknown. So how can we find the radius of the circle? Since this line PR is a chord, and the formula for finding the length of a chord of a circle is 2r sine theta over 2, we can equate it to line PR. Now line PR equal to 2r sine theta over 2. But line PR is 7 centimeters in length, and theta is the angle at the center. So what is the size of the angle at the center? We don't know. But from the circle theory, the angle at the center is twice the angle at the circumference. And we have this angle here at the circumference to be 60 degree. Therefore, theta will be 2 times 60 degree. Substitute here now. 7 equal to 2r sine open bracket 2 times 60 degree over 2. Here, 2 cancels 2. Now 7 equal to 2r sine 60 degree. Sine 60 degree is 0.86. So 7 equal to 2r times 0.866. 2r times 0.866 is 1.72r. So 7 equal to 1.732r. Dividing both sides by 1.732. Here, 1.732 cancels 1.732. And here, 7 over 1.732 is 4.0416. So r equal to 4.0416 centimeters. Now substituting r equal to 4.0416 here, area of circle equal to 22 over 7 open bracket 4.0416 all squared. Now area of circle equal to 51.337 centimeters squared. So we can substitute it here now. Now area of segment A and segment B equal to 51.337 centimeters squared minus 20.39 centimeters squared minus area of segment. 51.337 centimeters squared minus 20.392 centimeters squared is 30.945 centimeters squared. So area of segment A and B equal to 30.945 centimeters squared minus area of segment D. What is the area of segment D? To find the area of segment D, since we have this angle here, we apply the formula area of segment equal to area of sector minus area of triangle. Area of sector is theta over 360 pi r squared, and area of triangle is half r squared sine theta. So area of segment D equal to theta over 360 pi r squared minus 1 over 2 r squared sine theta. Factoring out r squared, area of segment D now equal to r squared open bracket theta over 360 pi minus 1 over 2 sine theta. Now substituting r equal to 4.0416, theta equal to 120 degree and pi equal to 22 over 7, area of segment D equal to 4.0416 all squared open bracket 120 over 360 open bracket 22 over 7 minus 1 over 2 sine 120 degree, which if we press your calculator equal to 10.0393. So area of segment D equal to 10.0393 centimeters squared. Substitute here now. Area of segment A and segment B equal to 30.945 centimeters squared minus 10.0393 centimeters squared, which is 20.9057 centimeters squared. So area of segment A and segment B equal to 20.9057 centimeters squared. To find the surface area of C now, if you look from this triangle here, PST, if you subtract the area of this segment D, you're going to be left with the area of this C here. So we can form an equation that area of C equal to area of triangle PST minus area of segment D. But here, we have that area of segment D is 10.0393 centimeters squared. If you substitute here now, area of C equal to area of PST minus 10.0393 centimeters squared. But what is the area of triangle PST? The formula for finding the area of a triangle is half base times height. So what are the base and the height of triangle PST? We don't know. But recall that in a right angle triangle, the base and the height are the sides that are perpendicular to each other. So let's say this is the base and this is the height. So now we can substitute here that base is line PT and height is line ST. So now area of triangle PST equal to 1 over 2 times line PT times line ST. So what are the length of line PT and line ST? Recall from here, this line PR, line PT and line RS are equal in length. So since this is 7 centimeters, this and this must also be 7 centimeters in length as well. So line PT equal to 7 centimeters. Substitute here now. Coming back to line ST, to find its length, since this is a right angle triangle, we can use the Pythagoras rule. The Pythagoras rule states that the square of the hypotenuse of a right angle triangle is equal to the sum of the squares of the two other sides. Hypotenuse is the side facing the right angle, which is this side here. So we can substitute hypotenuse equal to 7 centimeters plus 7 centimeters, which is 14 centimeters. Line PT is 7 centimeters and line ST is unknown. So by Pythagoras now, 14 squared equal to 7 squared plus line ST squared. Making line ST the subject, line ST equal to square root of 14 squared minus 7 squared, which if you press the calculator equal to 12.1 approximately. So line ST equal to 12.1 centimeters. Substituting here now, area of triangle PST equal to 1 over 2 times 7 times 12.1, which is 42.35. So area of triangle PST equal to 42.35 centimeters squared. Substituting it here now, area of C equal to 42.35 centimeters squared minus 10.0393 centimeters squared, which is 32.3107. So area of C now equal to 32.3107 centimeters squared. Now since we have the area of C to be 32.3107 centimeters squared, if we add it to the area of segment A and segment B here, we are going to have the total surface area of the blue colored portion. So area of blue colored portion now equal to area of segment A and B plus area of C, which equal to 20.9057 centimeters squared plus 32.3107 centimeters squared, which is 53.2164 centimeters squared. So we found the total surface area of the blue colored portion to be 53.2164 centimeters squared. And here we have the area of triangle PQR to be 20.392 centimeters squared. Thank you for watching. Please subscribe to the channel and click the notification button for more videos.